Hello, welcome back to our series on LangChain4j framework. Today in this tutorial, we are going to learn about the chat model listeners. We are going to see how we can create the chat model listeners, how we can register them, how we can decide the sequence of their execution, and then we are going to build a very simple application with multiple chat model listeners, and finally we will test the same. When it comes to the LangChain4j framework, if we have to interact with the LLM, we can do that with the help of chat model interface. And if we have to observe this interaction, this is where the concept of chat model listeners comes into the picture. You can think of them as an event handlers that gets notified before the request is sent to the LLM and after the response is received from the LLM. This response can be a successful response or it can be an error response. When it comes to the chat model listener, it is an interface which consists of three default methods. First one is the onRequest method, then we have the onResponse method, and then we have the onError method. OnRequest method is called before the request is sent to the LLM for processing. And once the LLM has successfully processed the request, in that case onResponse method will be called. And if there are any errors during the request processing, in that case onError method will be called. So this is how our overall request flow will look like. When we have to interact with the LLM, we make use of the chatModel.chat method. Before the request is sent to the LLM for processing, the onRequest method of the ChatModel Listener will be called, wherein we can inspect our request object. Post this method, the request will be sent to the LLM for processing. And once the LLM has processed our request, we will receive the response. Now there are two possible scenarios here. First one is the positive scenario wherein there were no errors during the request processing. In that case, this particular flow will be executed wherein first the onResponse method of the chat model listener will be called. Here we will get the details of our response which we can inspect. Post this method, our application will finally receive the response which we can utilize further. Another scenario is the negative scenario wherein there was some error during the request processing. In that case, this particular flow will be executed wherein the onError method of the chat model listener will be called. Inside this method, we will get the details about error stating what went wrong. And once the onError method has been called, finally our application will receive the response containing the details which we can utilize further. Now let's understand how we can create our chat model listener and how we can register it with the chat model. So when it comes to creating our listener, in that case, all we need to do is we need to create the new Java class that implements the chat model listener interface. Now this chat model listener interface consists of three default methods. First one is the onRequest, second one is the onResponse, third one is the onError. So based on our requirement, we can override these three methods. So let's say before sending the request to the AI, if we have to perform certain operation, then we can override the onRequest method wherein we can add our custom logic. Similarly, after receiving the response, if we have to perform anything, we can override this method onResponse and we can add our logic. Now this is how we can create the chat model listener. Once the chat model listener has been created, we need to register it with the chat model. For this, there are two approaches. First one is the auto registration. Once we have created our custom model listener, in that case, all we need to do is we need to define it as bean. One of the ways we can annotate our class with @component annotation. Behind the scenes, our custom chat model listener will be automatically registered with the chat model that we have defined inside our application. Second approach is the manual registration, wherein while creating the chat model bean, we can define what all listeners we want to register with this particular chat model. Now when it comes to our application, there can be more than one chat model listeners, and if you have to decide the sequence how each of them should be executed, there are two possible approaches. First one is @order annotation provided by the Spring framework, wherein we can define the sequence for each of our chat model listener. Another one is the manual approach, wherein while creating the chat model bean, we can pass the list of listeners in the sequence how each of them should be executed. Now when it comes to the chat model listeners, we need to remember one point. The chat model listeners are executed in the same sequence when it comes to the request, response or error. So let's say we have the two listeners, listener A and listener B. For listener A, we have given the sequence as 1, and for listener B, we have given the sequence as 2. So when it comes to the request processing, the onRequest method of listener A will be called first, followed by the onRequest method of the listener B. And once the AI has processed the request, then the onResponse method of the listener A will be called, followed by the onResponse method of the listener B. Now we are going to create a very simple chat-based application wherein user can ask any query to the LLM. And inside our application, we are going to create 3 chat model listeners for 3 different use cases. So first one is the content moderation chat model listener, which will look for the sensitive keywords in the request which is sent by the user and also inside the response which is produced by the AI. Second one is the logging and timing listener, which will log the request that has been sent by the user. Also, it will log the response that we have received from the LLM, and it will measure the time it took for the LLM to process our request. Third one is the token usage listener, which keeps the track of the tokens that were utilized for processing a request. Also, it keeps the track of the total tokens that were utilized for processing all our requests. So this is how our overall request flow will look like. We will make use of the chat model.chat method to send the request to the LLM. Before the request is sent to the LLM, the onRequest method of all the 3 chat model listeners will be called in the sequence. Post this, the request will be sent to the LLM for processing. And once the LLM has processed the request, onResponse method of all 3 chat model listener will be called in the same sequence that we have defined here. Finally, our application will receive the response for further processing. So this is how our overall project structure will look like, wherein we are going to create the Spring Boot based application. The name of our application is LangChain4j Chat Model Listeners Demo. At the very top, we have the Spring Boot main class. Then inside the controller, we have the Chat Model Listeners Demo controller class containing one REST endpoint for accepting the request from the user and for sending back the response. Then inside the listeners package, we have the 3 listeners that we have seen just now. First one is the content moderation listener. Then we have the logging and timing listeners. Then we have the token usage listeners. Inside the resources folder, we have application.yml containing basic configuration related to our LLM. Then we have the pom.xml containing project related configuration. Now let's go through our code base starting with the pom.xml. At the very top, you will notice we are making use of Spring Boot version 3.5.10. Then for Java, we are making use of version 21. And when it comes to the LangChain4j, we are making use of the latest stable version, which is 1.10.0. Coming to the dependencies section, first we have added the Spring Boot starter web, which will help us to create the REST APIs. And in order to integrate the LangChain4j, we have added the LangChain4j OpenAI Spring Boot starter dependency. Now we have added the OpenAI specific dependency. So in our case, for demo purpose, we are going to make use of the free models that are offered by the Open Router platform. And these models are compatible with the OpenAI standards. That is why we have added the OpenAI specific dependency. Then inside the dependencies management section, we have added the LangChain4j BOM for the version management. Now coming to the application YML, at the very top, we have defined the name of our application. Then we have defined the configuration related to our LLM with the help of the properties that are provided by the LangChain4j framework. So here you will see we have defined the configuration with the help of LangChain4j OpenAI chat model. First, we are setting the base URL. Since we are making use of the Open Router platform, we have set the base path of the Open Router platform here. Then we are setting the API key. So this API key will come from the environment variable. So the name of the environment variable is open router underscore API underscore key. Here we need to pass our open router API key. Then we have defined the model name. In our case, we are going to make use of the free model which is provided by the Open Router platform. And the free model is the DeepSeek R1. This is the model ID that we have obtained from the Open Router platform. Then for logging request and response, we can make use of these two properties, which is the log request and another one is the log response. Now coming to the Spring Boot main class, this is the standard Spring Boot main class which will bootstrap our application. Now coming to the listeners package, we have created our 3 custom chat model listeners starting with the content moderation listeners. In order to define it as listener, we need to implement the chat model listener interface. And if we open this interface, we have 3 default methods. First one is the on request, next one is the on response, third one is the on error. Based on our requirement, we can override any of them. Now coming back to the content moderation listener, once we have created the content moderation listener class, in order to register it with the chat model, we have defined this as the Spring Bean with the help of @component. So our listener will be auto registered with the chat model. Then we have defined the sequence with the help of @order annotation, and we have given the number as 1. So whenever we will receive the request from the user, first content moderation listener will be executed. Now based on our use case, we are overriding the 2 methods of the chat model listener. First one is the on request, next one is the on response. So what this content moderation listener is doing is, whenever we will receive the request, it will look for the sensitive keywords within the request. Also, it will look whether the request that is sent by the user contains the email or not. So for that, we have defined the regex pattern to identify whether the email address is present inside the request which is sent by the user. So if we expand this on request method, here you will see we have defined the logic which will check for the sensitive keywords as well as it will look for the email pattern. Now when it comes to the on request method, we receive the chat model request context object which is provided by the LangChain4j. Now you can think of this object as the package which contains a lot of other objects which we can make use of. So in our case, we need to analyze the request which is sent by the user, and inside that request we need to analyze what message that user has sent, whether it contains the sensitive keywords or it contains the email address or not. So first we are extracting the request object with the help of context.chatRequest. This will give the chat request object. Now chat request object can hold the messages, so we are calling the dot message, and since we can have more than one messages, so we are calling the for each, and inside for each we are identifying what type of message it is, whether it is a user message, it is a system message, or it is a AI message. So based on that, we are checking the message which is sent by the user. If it is a system message, we are checking the text of the system message. If it is a AI message, we are checking the text of the AI message. Once we have received the text, we are calling our utility method, or we can say we are calling our helper method, which is the check content. If we expand this method check content, here you will see it is looking for the sensitive keywords within the text that has been received, and also it is looking for the email pattern. If any sensitive keyword is found, we are simply logging the same by specifying the source. It can be request or response. Also, what is the sensitive keyword that has been found. Similarly, if the message contains the email address, we are logging the same. Now when it comes to the on response method, here you will notice we have the chat model response context, which also contains some other details apart from the request. It will hold the response object as well. Response object will contain the response that has been given to us by the LLM. So here you will see from the context, we are extracting the chat response object. Since it contains the text which is sent by the AI, it will be present inside the AI message, and then finally we are extracting the text. This is nothing but the text response that the AI has given back to us. So once we have the response string, similarly we are calling the chat content method, which will look for the sensitive keywords and the email address, whether those are present inside the response which is produced by the AI. So this is the simple content moderation listener wherein we are checking for the sensitive keywords within the request as well as within the response. Next we have the logging and timing listener. So here the overall approach will remain the same. In order to define it as the chat model listener, we are implementing the chat model listener interface. We are defining the order. We are registering with the chat model by defining it as the Spring Bean. Now the overall purpose of this chat model listener is it will log the request that has been sent by the user. Also it will measure the time it took for the AI to process our request. So here you will see Based on a requirement, we are overriding all three methods. First one is the onRequest, next one is the onResponse, third one is the onError. So starting with the onRequest method, here you will see at the very beginning what we are doing is from the chat model request content, we are calling the dot attributes method. Now if we have to share some information between onRequest, onResponse and onError, then we can make use of the map which is available inside the attributes. Here you will see we have the map of object. Now inside this map we can add anything, and once this information has been added we can use it anywhere. For example, while processing the request, if we are adding something inside this map, we can extract the same when it comes to the on response or on error. Since we have to measure the time it took for the LLM to process our request, what we are doing is we are adding the start time inside this map with the help of attributes. So here you will see we are calling the dot attributes, then inside the map we are adding the start key which is request start time, and then we are adding the value. At this stage we are considering our request processing has been started. Then we are logging the request which is sent by the user. So in order to get the request object, we are making use of chat model request context, within which we have the list of messages, and based on the message type we are logging the request. So we have created one helper method. Inside this we are only logging the text, or we can say message, which is sent by the user. So this was the purpose of on request method. Now once the request has been processed by the LLM, on response will be called. So first we need to calculate the time it took for our request to be completed. So in order to calculate the time, we need the start time at which our request processing was started. And since we stored it inside the attribute, first we will extract it. So here you will see from the response context object, we are calling the dot attributes, and then we are calling the dot get method to get the value of the start time key. So once we have the start time, we will calculate the total duration by calling the current time milliseconds minus the start time, which will give us the total duration in milliseconds. And finally, we are logging the response that we receive from the LLM. Also, we are logging the total time it took for the LLM to process our request. So this was the on response method. Now when it comes to the on error, let's say there was some error which was encountered while processing our request. In that case, on error method will be called. In that case also, we need to calculate the time it took for our request to be processed. So from the error context, we will call the attributes method, and then we will call the get method by passing the key name. Once we have the start time, we will calculate the total duration, and finally we are logging the error. Now when it comes to the error object, we have the chat model error context, within which we can call the dot error method, which will give the details of the error that was encountered. And here we are simply calling the dot get message to print the error response. And finally we are printing the time it took for our request to be processed. Now coming to our third listener, which is the token usage listener. Here also the overall approach will remain the same, and we have given the order as 3 for this particular listener, which is the token usage listener, which means it will be executed at last compared to these two other listeners. Now when it comes to the purpose of this listener, it will keep the track of the number of requests that we have received, and also it will keep the track of the tokens that were utilized for processing this request, as well as the total tokens that were utilized for processing all our requests. So here you will see we are overriding the two methods, on request and on response. If we expand this on request method, here we are just incrementing the request count by 1. So whenever we will receive the request, we will increment the total request count by 1. And here we are making use of atomic long for the thread safe operation. So here you will see we are incrementing and getting the value and simply printing the same. And once our request has been processed, now we need to keep the track of the total tokens that were utilized. For this, we will make use of the on response method. Inside on response, once we have received the response from the LLM, inside that we will have the token usage method, which will give the token usage details. And based on the token usage details, what we are doing is we are printing the same. So here you will see token matrix updated. the total tokens that were utilized in this request can be obtained from the token usage object that we have received here. Then we are calling the input tokens that were used, the output tokens that were used for this request, and the total tokens that were used for this particular request. So all three details we are printing here. Now in order to track the global token usage, we have these two atomic long variables within which the total usage will be stored. So for this, we are calling the add and get method. So whenever we will receive the response, we will add the tokens to our global count for input as well as the output token. And finally, we are printing the same. So here you will see we are printing the global tokens with the help of total input token usage, total output token usage. Also, we are printing the total tokens that were utilized for processing all our requests. Now we have seen these three listeners. Finally, we will look at our controller class within which we are going to create one simple endpoint for accepting the request from the user and for sending back the response. So here we have defined the base path for our controller, which is API v1. Then we have created one simple chat endpoint, which is of type post, and the path suffix is /chat. In order to accept the request from the user, we have created map of string, which means user will send the request in the form of key value pair. It is going to be the JSON request. Similarly, in order to send the response back to the user, we have created map of string of object, which will also going to be the JSON response in the form of key value pair. So if we expand this method, here you will see from the request, first we are extracting the message that is sent by the user. So we are assuming user will send the message inside this key, which is the message. Once we have the user message, we need to call the LLM. For that, we are making use of the chat model. So chat model will be auto wired by the Spring framework. And then we are calling the chat method by passing the message which is sent by the user. Once the LLM has processed our request, we will receive the string response back. And finally, we are mapping it inside the map of string of object under this key, which is AI response, and we are sending it back to the user. Now when this chat model.chat method will be called, in that case, on request method of all these three listeners will be called. Then the request will be sent to the LLM. And once we receive the response, then on response method of all these three chat listener method will be called in the sequence. Yeah, so that was all regarding how we can create our chat model listeners, how we can register them with the chat model, and how we can define the sequence for them. Now let's test our application. But before starting our application, we need to pass our open router API key under this variable, which is open router underscore API underscore key. Yeah, so now we will test our application. First, we will test a positive scenario wherein we are going to send a simple query to the LLM which does not contain any sensitive keyword. For this, we will send the post request to API v1 chat endpoint, and the message content is list exactly 5 features of Spring Boot. Keep the response concise and limited to maximum 5 lines. So here we are trying to produce the short response so we can also go to the logs. So when it comes to our application, since our query does not contain any sensitive keyword, no output will be logged by this content moderation listener. We will only see the response from these two listeners. Logging and timing listener will log the request and response content. Also, it will log the time it took for AI to process our request. And the token usage listener will log the tokens that were utilized for processing our request. So when we will send the request, so yeah, we have received the response back from the LLM. If we jump to the application logs, here you will see we are seeing the logs from the logging and timing listener, which is printing the request content. Then we are receiving the logs from the token usage listener, which incremented the request count by 1, and our total request count is 2. Once the LLM has processed our request, we receive the response back from the LLM. So the response content is printed here with the help of logging and timing listener. And finally, we are printing the tokens that were utilized for processing this request with the help of token usage listener. Here you will see the global total token usage count is also maintained. Yeah, so now we are going to test one another scenario wherein we are sending some sensitive info within the message. Here you can see it contains the email address and the password. So when we will send the request, we are expecting that the content moderation listener will print the logs related to the sensitive keyword and email address. Also, when the LLM will send the response back, if it contains the sensitive keywords or the email address, it will also log the same. And these two other listeners will be also be executed in the sequence defined. So when we will send the request, we are expecting content moderation listener will print the required logs. So yeah, you will see we have received the response back from the AI. Now if we check our application logs, here you will see first the content moderation listener has printed the log statements related to the sensitive keywords and the email. So these two sensitive keywords were found, password and secret. Also it states that the request content contains the email address. Then the logging and timing listener printed the request content. Then the token usage listener incremented the overall request count by 1. And once the LLM has processed our request, here content moderation listener is saying the response contains the sensitive keyword which is password. So here you will see password keyword is present here. That is why this particular log statement was printed. And then the logging and timing listener is printing the response that we receive from AI. And finally, here you will see the token usage were also printed, including the tokens that were utilized for the current request as well as the total tokens that were utilized for processing both the request. Now I will showcase you one negative scenario wherein the onError method of the chat model listener will be executed. So for this, we have passed the incorrect open router API key while starting our application. So when chat model will try to process our request, it will receive the 401 from the open router platform. So if we go to our listeners, there is one listener logging and timing listener inside which we are overriding the onError method. And when the error will be encountered, it will print the error response that we have received. Also, it will print the time it took for our request to be processed. So now when we will send the request, we are expecting we will receive the error from the open router platform and onError method should be executed. So here you will see we have received the 500 internal server error since we have not added any error handling logic in case of our controller. So if we go back to our logs, here you will see first the logging and timing listener was executed stating sending request to the LLM. Then token usage listener incremented the request count by 1. And when LLM tried to process a request, error was encountered. In that case, onError method was executed stating the error message that we have received. Also, it printed the duration it took for our request to be processed. So this is how you will see onError method is also getting executed if there are any errors during the request processing. Now when it comes to the chat model listeners, if there are any exceptions encountered within the on request, on response or on error methods, those exceptions are simply ignored. So in order to demonstrate that, we have modified our content moderation listener on request method within which we are throwing one simple runtime exception with some custom message. So when we will send the request, our request will normally be processed and the runtime exception will be ignored. So now we have sent the request and we will wait for the response. So here you will see our response has been processed successfully. And if we check the application logs, here you will see an exception occurred during the invocation of chat model listener. This exception has been ignored. So this message has been produced by the chat model listener utils. And if we look at this utils class, here you will see if there are any exceptions within the on request, those are simply getting ignored and this message has been printed. An exception occurred during the invocation of the chat model listener. This exception has been ignored. Similarly, within the on response method also you will see the exceptions are getting ignored and same is the case with the on error. Yeah, so that was all regarding how we can create the chat model listeners, how we can register them and how we can define the sequence for each of them. For this, we have also written one detailed article which you can go through if you are interested. Also, the code base that we discussed within this tutorial is uploaded on GitHub. You can simply check out the code, set your open router API key and test the same. Yeah, so that was all from my end. I hope you found it useful. Thank you.